Okay, let's have a look here. We want to solve that cubic. Not too bad. So if I solve here the quadratic, why isn't my pen working now? I'll use blue. Z squared minus 10z plus 28. So z equals minus b plus or minus the square root of b squared minus 4ac. B squared minus 4ac, that's minus 12 all over 2a. So that's 10 plus or minus root 4 times minus 3 over 2. So that's 10 plus or minus 2i root 3 over 2. So that's 5 plus or minus I root 3. So plotting those, okay, 1, 2, 3, 4, 5, I, 2i, I, and minus I, minus 2i. The first one is 2. And then 5 plus I root 3. And then 5 minus I root 3. And this we have to verify is an equilateral triangle. So we can get this distance, we can get this distance, and we can get this distance. Well, this distance is the easiest one to get. That's 10 units because of the real components are about 5. So if we just label them A, B, and C, the distance BC is 10. The distance AC will equal the distance AB because it's an isosceles triangle, because this length and this length are equal and it's on this axis here. I mean, I guess if you want to, you can calculate them each separately if you want, if you prefer to not take any chances. So AC would be, let's see, this distance here is 3 units and this height here is 5 units. Oh, that's not 10 units. How careless of me. I was looking at the 5s. I should have been looking at the root 3s. That is 2 root 3. Because that's root 3 and that's root 3. So I should have said, how careless of me. I should have said 2 root 3. I was focusing on the 5s when I should have been focusing on the root 3s. Okay. So that's a root 3 and a root 3, 2 root 3. Okay, let's get the AC now. So that would be square root, so not a 5, a root 3. Square root of 3 squared plus root 3 squared is the square root of 9 plus 3, which is the square root of 12, which is 2 root 3. Which is what it should be. And then likewise for AB, that would be the square root of 3 squared plus root 3 squared, which is the same thing, 2 root 3. And that, if you want to be clear how I got the 2 root 3 for BC, it was root 3 plus root 3, which is also 2 root 3. So I think that's okay for the first part. All right. The second part is nice. We want to calculate the product of Z1 and Z2. So here we just have to add the angles and multiply the moduli. So it's 2 times 3 is 6, and then it's cos pi over 6 plus pi over 3 plus I sine pi over 6 plus pi over 3. So that's 6. And then here cos pi over 6 plus pi over 3, that's 0. And then change the cos to a sine, and that's 1i. So the answer is 0 plus 6i. Yeah, so that's a nice question. Multiplication of complex numbers in polar form mean you multiply the modulus, the 2 and the 3, and you add the arguments. Okay, lastly now, okay, I don't think the previous answer is going to help me. Never know, actually, it might. Okay, let's see. So just by rearranging this, I can get A plus IB equals minus 1 plus 5i over 2 plus 3i, just by dividing. I multiply above and below by the conjugate. And on the bottom, I'll get 4 plus 9. Then on the top, I'll get minus 2 plus 3i plus 10i minus 15i squared. So on the top, I have minus 2 plus 15. So that's 13 plus 13i over 13, that's 1 plus I, and that's in the first quadrant. The or is 1 and the theta is pi over 4. This is a common one. It's the 45-degree line. So it's probably one of like 3 that you should have memorized because it's pretty common and easy. There's the one where it's just a real component, just imaginary component, and then a 45-degree angle. So that's going to be, sorry, I said 1, I meant to say root 2, because that's the hypotenuse, root 2, because that's a 1 and a 1. So that's going to be root 2 cos 45 degrees plus I sine 45 degrees, and that's A plus IB. And now we have to power 11 it. So power 11, power 11. The 11 multiplies here. Root 2 power 11 doesn't do anything nice. It's going to be 2 power 11 over 2. I guess I'll just leave it like that. Cos pi over 4 times 11. So that's minus root 2 over 2. And plus root 2 over 2. So that's kind of helpful, because I can multiply the root 2 in, and that becomes 11 over 2 plus a half. And then I divide by 2, so that's minus 1. So I think that just ends up being 2 power 5 minus 1 plus I. I wonder if it's possible for me to check this. Let me see. Okay. Minus 1 plus 5 I. 2 plus 3 I. That's 1 plus I. Okay. Can't quite. Yeah. Yeah. It is 1 plus I. Times 11. Yeah. Two, 4, 8, 6, and 32. Yeah, I think that's right. Don't know why I'm doubting myself. I don't see any mistakes I made. Maybe because I just messed up with I originally thought it was 1, but it's definitely root 2. And that's definitely 1 plus I. So, yeah, I guess it's okay. Right, okay, that's that question finished.